In today's video, we'll be looking at another powerful LangGraph design pattern called routing logic. This technique lets your application decide which path to take based on what the user wants. We'll walk through a simple visual graph that shows exactly how routing decisions happen, and by the end, you'll be ready to implement this in your own projects. So let's start by answering what is routing logic. So routing logic is a branching mechanism where instead of moving in a straight line, your application decides where to go based on what the user says. Now observe this image and think of it like a traffic cop standing at a busy intersection, but instead of cars, you've got different type of requests like tell me a story, crack a joke, or translate the sentence. The traffic cop listens to each request and then waves it towards the correct lane, that is stories to the left, jokes to the right, and translations straight ahead. This way your app doesn't waste time or resources guessing what to do. It flows smoothly just like traffic that's been properly routed at a signal. Now to understand this better, let's take a look at this diagram. We start at the start node. This is where the user gives an input, for example, tell me a story. From there, the request goes to our validator node. The validator's job is to analyze the input and decide where to go next. That is, does it match a story request or a joke request? If it's a story, we go to the story node. If it's a joke, we go to the joke node. Both of these eventually land us at the end node, completing the whole flow. You can notice how there's no unnecessary back and forth. We go from user input to validation to the chosen path and then finally done. Now to bring this to life, let's first implement this workflow with hard-coded values and basic if-else statements. Then to make it more dynamic, we will integrate our LLM into this. So let's get started. Alright guys, so I've set up a fresh UV project inside my VS Code. The install dependencies are as follows: LangGraph, LangGraph CLI, LangChain, LangChain Grok, grandalf, and python.env. Make sure you've got your own Grok's API key. If not, go check out my previous videos on how to set that up as well. Now let's start writing our code. It's time to build our graph as we saw in the diagram. So let's firstly import our base model. So I can say from parentic import base model along with the field. Then we have to work with typing as well in this video. So I will be saying from typing import optional and also literal. So as we saw from our previous video that while invoking the graph, we have to make certain fields optional. So you can do that by using optional from typing. And now I can say that my graph state takes in my base model, and we have this user input which is a type of string, and we have its description as the user input to the graph. And we also have a key called decision, which is optional while invoking the graph, and it takes in two parameters, so we can define that with a literal. So it can be either a story or a joke, and also we have to specify its default value because we are keeping it as optional while invoking the graph, so it's mandatory to do that. And the description is the decision of the graph. All right, so now we can start defining our nodes as well. So I can say define my validator, takes in my graph state. We have our user's input, so state dot operator user underscore input. And now I can say if there is a story inside my user input, then I return the updated state, that is my decision becomes the story, or else it becomes a joke. All right, so story and a joke, story and a joke. Get rid of any typos, decision and a joke. Yeah, and now I can create a function for the actual routing of the graph. So I can say firstly we'll fetch the decision from our validator. So we can say fetch me the decision first, decision. All right, another typo right here. It has to be this decision, and if that decision equals to or equal to story, then I can just return here story. And if that's not the case, then I can return joke. All right, we'll see why we need this router function. Firstly, let's define our story and joke node. So I can say takes in my graph state, but we don't use that. So I can just say that print this is a story node, and I can just copy this again and change the name here. So I can say this is my joke node. All right, and now it's time to build a graph. So I can say builder equal to, firstly let's import our state graph and the starting and end nodes. So from LangGraph dot graph import start, end, and state graph. So state graph takes in my graph state. Then we build our graph by firstly defining our nodes. So my validator is my validator, and my story node is my story node. Then I have my joke node, and now it's time to define our edges. So firstly we begin at our validator. Now here comes the most important thing in this video, that is conditional edges from LangGraph. So here is the place that we'll be using our custom defined helper function, that is the router function. So I can say that if my function outputs story, then I can go to my story node. If it outputs the joke, then I go to my joke node. All right, so that is what we are doing right here. So from validator we go to our router, and if the router outputs the story node or story, then we go to our story underscore node, and if it outputs joke, then we go to our joke underscore node. All right, so that is the most important thing in this video, working with conditional edges within LangGraph. So you can find the documentation of the same in the description below. You can always refer to that. And now from either my story or my end or my joke node, we go to the end node. So I can just copy this one more time. I can say joke underscore node, go to my end node. Finally, what we do is we say my graph is builder.compile, and we can see this graph with the help of grandalf. So I can say graph.get underscore graph and then dot draw ASCII. All right, now let's print this state graph. Okay, all right, this has to be add underscore node, not add. Again something happened. I didn't save that file. Okay, yes guys, so we can see that our graph is being printed as we discussed in the workflow. So we have the start, validator, joke node, story node, and finally end. So now we can invoke this graph with a user's input. So I can say response equal to graph.invoke with a user underscore input set as tell me a story, and then we can print this response, right? So let's see that, and yeah, it goes to this is a story node. The decision was made as story, input was tell me a story, and if I say tell me a joke, you can see it goes like this is a joke node, user input tell me a joke. So it's working fine. Now to make this more dynamic, we will integrate our LLM into this. So let's do that now. All right guys, first things first, let's import our environment variable. So I can say from .env load underscore .env, call this function at the root with override equal to true, and then I can specify my LLM as chatgrok. We have to import chatgrok as well. So from langchain underscore grok import chatgrok, and we can specify a model along with the temperature value set to 0.8, So I'll just get the model's name. Yes, we'll be working with the Llama 4, and now we can make all of this more dynamic. So what we'll do is we'll keep the builder as same, and we have to improve on the nodes, right? So right here, what we can do is we can say prompt equal to, we have to make this dynamic now. So for that, I have to import the prompt template as we saw in the previous video. So from lang_underscore dot prompts, import prompt template, and we pass that right here with the template saying you are a helpful AI. Okay, we don't have to do that right here. We have to do that in the validator, right? Yep. Let's do that again. So I can say you are a helpful AI assistant. Your job is to decide if the user's input is a joke or is a story or a joke. Always respond with a single word, either story or joke. In our upcoming videos, we'll be seeing how to make this output from the LLM more deterministic. So it's fine for now, and we can say here is the user input. We pass that as a dynamic input, and now we can say that our prompt has some input variables, and that is our user input. Again, we'll create a chain. So I can say firstly we go to our prompt, and then we call our LLM. Then we say response equal to chain dot invoke. Chain dot invoke, our user input is our user input, and then we say something like return the decision as response dot content, right? Because it will be a AI message and we only want to get the content from it. So now router is fine. We can improve on this as well. So for that, let's actually do one thing. Let's say final underscore output in our graph state is a string. Would be optional at first, so we have to define its default value as well, and description would be the final output of the graph. And now what I can do is I can say something like prompt equal to prompt template is my tell me a random story, comma, not longer than 50 words. 50 is short. Let's do 100 words. All right. Now again we can say something like chain, go to our prompt, then call our LLM. We get the response back. We don't pass anything in the invoke function. We just have to call it like this. And then we say our final underscore output is the response dot content. And now I can copy this and paste it right here and just change some of the dynamics of it. So I can say tell me a random joke, not longer than 20 words. All right. So now if we again call this graph with the same input and run that again, we'll be able to see something. Let's see what is happening. All right, our input was tell me a joke, decision it's a joke. Final output, why couldn't the bicycle stand up by itself? Because it was too tired. All right, it was very cheesy and very rubbish, but it's okay. We get the idea as to how to work with our branching logic and the routing logic. So that was the whole purpose of this video. Let's do one more thing, one more run actually. Tell me a story just to be sure. Python main.py. Tell me a story, decision story. All right. In tiny cafe, a mysterious cat appeared. The owner, okay, it actually prints out a story, so that is good. So yeah, that is all the work that we have done for actually, work with our routing logic. If you want to see this inside a LangGraph Studio, we can do that by specifying a langgraph.json file inside a projects root directory. So yeah, we can refer to the documentation for the same as we did in our previous videos. LangGraph CLI, you install the dependencies, and then we specify our graph, that where is it located actually. So in our main.py, we have a graph, right? I just hope I don't mess up with the names and the spellings. Yeah, we have a graph. We can comment this out, and I can run langgraph dev, and that will open up my LangGraph Studio. And yeah, as you can see, LangGraph Studio has been fired up. You can see your graph printed in a nice UI. You can also interact with the same. So I can say something like user input, tell me a story, send this, hit on submit. Validator, let's see, our validator returned decision story. Final output is that same story. All right, so I can again check this out. Just one more run to be sure. I can say something like tell me a joke, press on submit, validator decision joke, and we get a final output. And that wraps up a dive into routing logic with LangGraph. Check out the repo and documentation link below. If this helped, give it a like, share it with your friends, and don't forget to subscribe for more LangGraph and AI workflows. Catch you in the next one.